Good morning. My name is Stefan, and I'm a member of the support team here at Sizeware. In the workflow today, I will show how we can calculate average log data within a defined zone of interest along our wellbore to calculate things like average porosity maps, and then where those maps might fit to enhance your current workflows. We'll start the workflow today by defining our well zones using the well zone generator. In Sizeware, well zones are defined as depths along a wellbore. In other softwares, you might have heard these called thicknesses or stages. We have three different ways of defining well zones in Sizeware, either based off a single formation and a fixed offset, between two formations, or along defined depth ranges. For today's workflow, I'm going to define it between two formations, the Crow Mountain top and the Crow Mountain base top. And then once I give it a name, in this case a WC, and select my wells, I can generate that zone. Here I'll show in the cross-section tool what that zone looks like. Here you can see I have the Crow Mountain top and the Crow Mountain base, and highlighted green is that zone generated at each of my wells. Now that I've defined this zone, I'm going to calculate the average porosity for my porosity curve at each well within this zone to calculate the average porosity at each of my wells in between the Crow Mountain and the Crow Mountain base. And to do so, we'll use our log curve well zone attributes tool. So the first step using the log curve well zone attributes tool is to select our wells. After that, I'll go ahead and select which area of the log curve I want to extract my values from. So this can be the entire well bore. It can be specified depths relative to formations or tops, or using just a defined well zone like the one we just created. So I'm gonna go ahead and use that well zone I just created. I'll grab my porosity curve, and finally I can control the outputs. So we can output this as three different types of data. There's a file, a log curve, or a well zone attribute. In Sizeware, a well zone attribute is simply just a numerical value defined to each well zone. In this case here, I'm looking for the average of values, and I'll implicit my average porosity at each well. Once I go ahead and run this, I can display the results on my base map as a ribbon. So here when I turn that on, you'll see at each of my wells that had that required input, I have a porosity value color-coded between 0 and 23%. I can go ahead now and take this step further and grid those values. I've already gone ahead and done that just to save some time. And you can see I've generated a porosity grid now. Now, this could be the end of the workflow in some cases. However, today I'd like to show how we might be able to use this porosity grid to enhance some of our current workflows. So the first example I have today is in regards to our volumetrics calculator. In case you're not aware, our volumetrics calculator is a tool in Sizeware that allows users to calculate recoverable hydrocarbons. And when we're running the volumetrics calculation, a porosity value is used to is often estimated for the entire area. However, with this porosity grid, I can now input that porosity grid as one of my inputs in this volumetrics calculation, adding another layer of complexity and accuracy to my volumetrics model. Here, instead of give a single value, I can grab that porosity grid. I can take this a step further and follow the exact same steps to generate a water saturation grid and add that to my volumetrics calculator too. The second example I want to show today is how I can use our porosity grid to compare against seismic attributes to look for relationships between the two. I've already gone ahead and run a few attributes, things like area to peak, area to trough, max and min values on my seismic in the area here. And the one I think shows really nicely is my absolute attribute. And here it is displayed on the base map. If I jump into our crossplot tool now, you can see I've defined on my y-axis the average porosity at each of my well locations, as we just previously calculated. And on the x-axis, I'm showing that average absolute value extrapolated from my seismic attribute map I just showed on the base map at the Crow Mountain formation top along each well. And in the case here, I'm looking at a really limited data set. However, you can see I've defined a relationship between the two with an r-squared value of about 82%, which is now a relationship I can use later on. In conclusion, in the workflow today, I've shown how we can calculate average log data within a defined zone along our well to create things like porosity maps. But this really could be any type of map, like a water saturation or permeability. In addition, I've shown two examples where these porosity maps can be used to enhance current workflows, either as inputs for our volumetrics calculations or to compare against seismic attributes using our crossplot tool. I hope you found today's workflow interesting and have a great day.